Okay, 6.1 example 3, last example in this section. It does, again, and you've noticed this through the notes, it just steps up the difficulty. One of the things that's really important is, again, dealing with those squared identities, is that when we have cot squared x, this is the cotangent of x squared. And what I'm actually going to do to verify this, before I plug anything in, I'm going to write this as the cotangent of x, which is cos x over sine x, and that's going to be squared, plus 1. And then I'm going to look at, is this equal to 1 over sine x, which is cosecant x, and that'll be squared as well. Now, one of the things I like to do when I verify is, if there is a simplification, I'll make it. I'm just going to put x equals pi over 6 here so I don't forget. But I'm going to split this immediately down. And it's really important when we verify or later talk about proving that nothing crosses the equal sign. We're going to treat the left-hand side and the right-hand side as totally separate entities and then see if we get the same value. Let's do the easier one first, if there is an easier one. X equals pi over 6. I'm going to try to make this as easy as I can. And the point pi over 6 on our unit circle is root 3 over 2 comma 1/2, which means that the sine of pi over 6 is the y coordinate. So that's going to be 1 over 1/2. That's going to be squared. 1 over 1/2 is 2, and 2 squared is 4. So when x is pi over 6, the right-hand side of that equation is just positive 4. The left-hand side's a little bit trickier. The cosine of x is root 3 over 2. The sine of x is still 1/2. That's going to be squared, and then I'm going to add 1. Now, before I square it, I'm going to clean this up, and that's going to be the numerator multiplied by the reciprocal of the denominator, and the 2's cancel. So that expression, root 3 over 2 divided by 1/2, is actually just root 3. So if I square root 3, I get 3. If I add 1 to 3, I get 4. The left-hand side is equal to the right-hand side, so we know that that equation is true. All right, for B here, I'm actually going to do all of them. If you notice on your formula sheet, you have several different versions of the Pythagorean identity. So I'm going to start right off the bat, and I'm going to use theta. Sine squared theta plus cos squared theta is equal to 1. That's our Pythagorean identity. The way that we get the other versions is we divide by either sine squared or cos squared. And I'm going to show both of these versions here. If I take the expression above and I divide both sides by sine squared theta, which is a totally valid mathematical operation because it is an equal sign. When I divide the sides, I end up dividing each and every term by sine squared theta. Well, sine squared divided by sine squared is 1. Cos squared divided by sine squared is the cotangent squared of that angle. And then 1 divided by sine squared is the cosecant squared of that angle. And we get one of the other Pythagorean identities on your formula sheet. And I'm going to try to sneak this other one in here, that if I do kind of, maybe not the opposite, but a similar operator, is that I could take this red Pythagorean expression and divide everything by cos squared theta. And I would have sine squared theta over cos squared theta plus cos squared theta over cos squared theta is equal to 1 over cos squared theta. So a very similar operation. I divided each and every term by cos squared. Now what's going to happen is sine squared over cos squared is tan squared theta. Cos squared divided by cos squared is 1, and 1 divided by cos squared is secant squared theta. Now, the idea of non-permissible values is very important. As soon as we have any reciprocal identity, it has a primary trig ratio in the denominator, so you would have to worry about those non-permissible values. So certainly the expressions I've written in black, or I've boxed in black and blue, are not true for every single angle, because you cannot take the tan of pi over 2. So that's not going to be a valid input for that angle. Pythagorean identities get used a ton, probably more so than anything else in this section. So we'll see a lot of time and a lot of practice with them. I'm going to put up this assignment at the end. Just keep in mind that for our kind of COVID self-isolation, I will be shortening it. So make sure you're reading Google Classroom very closely. All right, good luck. Please do email if you have problems. We can zoom in or certainly give you any extra help that you require.